Welcome to Sairam Trubli YouTube channel. Let us discuss Module 2 Voltage Stability Analysis Tools. In this, we have voltage stability assessment techniques. So, transient stability studies of a typical 500 bus system requires an hour of runtime, even for a single contingencies. See, in the transient stability analysis, how exactly it will occur? So, if suppose fault occurs, if suppose any abnormal condition occurs, it gives subtransient, transient, and steady state analysis, right? So transient in the sense that it's a middle one, right? So if suppose 100 buses will be there is a fluctuation occurs and then there is a variations occurs, and 100 machine systems requires an hour to hour of runtime. So if suppose the some of the machines in the generating stations, it will be working throughout day, throughout 24 hours uh, in the power supply system. So to maintain that voltage stability and voltage readings or voltage like mapping, so it's a constant, continuous, right? Next, angle stability analysis technique or angle analysis of angle stability. We have there is a three methods like direct method, indirect method, new methods, right? So direct method energy functions, Lipnovo and equacy, right? In the direct methods, indirect methods we have a RK14. These are the indications, okay, like numbering we are giving or some of the abbreviations we are giving. Indirect method EM and trapezoidal. So right, new methods here: ADP, expert systems, ANN, artificial neural network, fuzzy logic, and see here the direct method and indirect method, it's presently available existing system, and new methods, artificial neural network and fuzzy logic, expert system, ADP, GA, these are implemented one because it we are making this power system into smart grid. I mean, it we are making into a smart one, right? So by keeping some of the sensors and some of the mm, automatic devices, so new methods we are going to implement over here. So state estimation, sorry, in this analysis angle stability, uh, direct method, indirect method, the new methods, just will compare once again. Direct method, for example, I'll tell you, uh, right, there is a before the SCADA and then PLC implementation in the power supply system or power distributed system or power substations. So there is a normal working condition. Normally, power supply will be generating in the power stations and directly I mean coming from the power station to the consumer side. We have a small one, the step down transformers, right? In the indirect method, we have a RK14 and then 4 and an EM trapezoidal. Just like implementing like SCADA PLC, just its implementation, and the new methods, these four for the analysis angle stability techniques. Next, we have state estimation, energy management systems run in real time to compute and maintain security of operation at a minimum cost. The power system measurement provides information to the SC program for processing and analysis. The functions of performed included topology processing, which gather data about breakers and then disconnect switches, and state estimation, SC voltages, and mm, voltage angle obtained by the buses using a weighted least square methods. Direction of inaccurate data is obtained from the network parameters, tap changing transformers, shunt capacitors, and breakers. The general SC model discussed below is based on the steady state functions, right? So energy management system includes energy demand side management, right? So how much demand is needed for the power supply and how much energy producing, that also needed for the estimation. Real-time compute and real-time applications, like real-time what is needed, and maintain the security operation, maintain minimum cost. So security is also very much important for the power supply system. If suppose if you are placing two wires into the transmission lines, what happens if suppose thefting occurs? So that's a drop, right? So whatever we are generating, it's a misusing, right? So that is not at all counted in the power supply system. So that security also we needed. And um, the power system measurement provides information SE programs processing analysis. So measuring devices also, like just to go back to 10 years, that is a person, he has to come to home and then he has to read the meters. But at present we have a automatic, right? Just a digital meters we have. The function performed including topology for processing, which gather the data about the breakers and disconnecting switches. So smart grid includes like it's a topology in the sense it's an interconnection system, one to one connection, one to one bus connection. So how much breakers we're using, circuit breakers, and it gathers data, how much transformer is required and how much transmission lines length required and everything. And state estimation voltages angle obtained for all the buses using weighted least square methods. Detection of inaccurate data is obtained from the network parameters. And tap changing transformer is for directly like variation of voltage or changing the voltage levels, right? Shunt capacitors will be there for eliminating the disturbances or whatever. And then circuit breaker is break a circuit when fault occurs or abnormal condition occurs. And the general SE model discussed in the next class based on the steady state functions. Okay, just once again we'll revise concepts. First we discuss voltage stability analysis, angle stability analysis techniques, direct method, indirect method, and new methods. So direct, indirect, we are going to eliminate, and we are going to implement new methods in the power system stability analysis technique. Next we discuss stability analysis estimations. So how the estimation occurs in the power supply system, right?